All right. These are this is, I think, one of the problems from one of the homeworks or something similar to it, where you had an angle bisector. Now, this isn't an angle pair we talked about yesterday, but it is one that we've talked about in the past. What does an angle bisector do? What does that mean? Of course, an angle bisector bisects. What does bisects mean? Okay, what do you got? Bi means two, okay. So what about the two? Okay. Well, no, not necessarily intersecting lines. What is? Okay, this is maybe one of those points then where this is maybe a point where we pull out our note cards, right? This is why we have note cards. So why don't you pull out your note cards and look up the definition of angle bisector that you wrote down. See if you can find it.
How many note cards do we have in a year?
Well, I don't know, a few hundred. There's a lot of vocabulary here.
How did they go through 170 note cards?
Because there's that much vocabulary that we need to know. Because again, this is where the problem comes in, is that on a test it'll say something like BD bisect angle ABC, and if you don't know what bisects means you don't know at all what to do with these variable expressions.
The what's it called?
Bisects, or bi-angle bisector. What do you get, Brittany? Two angles that are congruent. Very important. Not just that divides them two angles, but they're congruent. And what does congruence mean to us mathematically? Equal measure. Okay? The definition of congruence is that two angles are congruent if they have equal measure. If and only if they have equal measure. It's a biconditional. So that means two angles are congruent if they have equal measure, and two angles have equal measure if they're congruent. It's a biconditional. So that means I do what with these variable expressions? Yeah, they have equal measure, so set them equal to each other. Try again. And then we just go ahead and do our algebra. Cancels. 15 cancels 1x. Or just x. Oh, and you need to do division step. It's easy. So there we are. X is 15. I found the value of x. Now, if I needed to, I could find the measure of the angle, couldn't I? I could substitute that back in. Doesn't ask to here. Here, all it has to do is set up and solve the equation. But we can do that with bisects. Okay, let's get rid of some stuff here. It's okay. Let's just look at these two angles here. What type of angle pair by name do I have in this picture? What would we call that angle pair? What? Okay, adjacent angles share a vertex, which these two angles most certainly do. They share a side. This angle has two sides that are raised going this way. This one has two rays going this way. They don't share a side. So they have that first property. They have the third property. They don't overlap, too, but they don't have that second property of sharing a side. So not quite adjacent. What is the other one then? What's another one we learned yesterday? What did he say? Vertical angles, okay? These are vertical angles. And again, if this isn't something you know, then this is where you should have a note card. I should spell that out. Okay? Where I should have a note card that on one side has the picture, the other side has vertical angles, the name of the angle pair. And second, the relationship that these angles must have, they must be congruent. Vertical angles are always congruent. That's one of the theorems we had yesterday. You need to be able to identify them on site by name and relationship so that you can set up and solve equations. That's going to be important. We're going to use vertical angles all the time. We're going to use the spec, vertical angles are congruent, all the time. It's a very common one. So you need to be able to identify them. That's something you need to just memorize. And again, flashcard yourself on it. Make the note card. Flashcard yourself. It's really helpful. All right, now we've identified them. Now we know their relationship. We know our very important theorem, vertical angles are congruent. Okay, there's my very important theorem that we needed to learn and one we will use frequently. So what does that mean algebraically? What do I do with these two? From an algebra standpoint now, how do I set up and solve this problem? Congruence means what? Equal measure. That's our definition of congruence. Congruence means equal measure. So what am I going to do with those two measurements? Because those are measurements. Set them equal, yeah. Equals 6x minus 10. And we solve it. Cancels. 40 equals 4x. Cancels. Divided by 4. X is 10. Now that I know x has a value of 10, I can do a lot of different things. I can substitute it in to see if I'm correct. I can check my answer by putting 10 in for x in both spots. 2 times 10 is 20. 20 plus 30 is 50. 6 times 10 is 60, minus 10 is 50. Sure enough, 50 and 50, those are congruent angles. Not only that, though, but now I could, if I needed to, find the measure of this. Because what kind of pair do we have between the 2x plus 30 and the n here? What kind of pair is that? What do we name that angle pair? Linear pair, yes. And linear pairs are what property? What's the relationship for linear pairs? They are adjacent and... Are they congruent? No, they are supplementary, which means what? They don't equal 180, they add up to 180. Okay, we want to be really careful about that, because if we say they equal 180, then I might say 2x plus 30 equals 180 when I write down my equation. But if I say the right phrase, they add up to 180, now I know I need to add them, and they have to add up to 180. But however, I know this angle is 50, so what's this angle going to have to be? 130. And so does this one. So by solving that problem, not only do we get the value of x, we find the measures of the angles, and we find the measures of the other angles that we weren't even working with so far. It's like putting together a puzzle. We use one fact to build and build and build and build. And that's what we do. So here we go. There's another note card you should probably have made up. It's got the two angles that form a linear pair there identified. We identify them as a linear pair. We say they're supplementary, which means they add up to 180 degrees. We put that on a note card. And then again, that's something we flash ourselves with. Do I know the difference? Am I able to identify these angle pairs? And you need to make sure you're doing these now, because we're going to throw a whole bunch more angle pairs at you tomorrow. Alternate interior, alternate exterior, all this different angle pair stuff. You're going to have to be able to identify them and know their relationship. That's what we're working on. I'm going to tell you what they are. You're going to copy them down on note cards, and hopefully you're going to learn them and memorize them and be able to work with them. Now again, we try to use this to set up to solve equations. This is one of the problems you may have done last night. It was problem number 39, I believe. Hold on, let me find my page here. Because we're marching around all these different pages. Yeah, 39 on page 40. It said in the instructions, angle A and angle B are complementary. What does complementary mean? Add up to 90. Thank you. Very good language there. Okay? They add up to 90 degrees. So what does that mean? I took my two angle measures and added them up to set them equal to 90. Did the math. Combined like terms, solved it out. And when I was done, I substituted back into the original equations. All right? 3x plus 2 became 3 times 23 plus 2 because x is 23. X minus 4 became 23 minus 4 because x is 23. And I got 71 to 19. Do those indeed add up to 90 degrees? Yes, they do. We're in good shape. Knowing our vocab, setting up problems, solving them. That's what we're about. Here's another one. And we'll pull it out of last night's homework. Say number 33. We had 2y and 3y plus 30. This is not drawn to scale, but that's okay. And 4x minus 100 and x plus 5. Those are my angle pairs that were given. This is problem 33 from last night. Said find the values of x and y. So you don't have to find the angles, you just have to find the values of x and y. I've got choices here because I've got so many things going on, but what I want to do is I want to work with them one variable at a time. So pick, what do I want to work with first, the x's or the y's? Pay attention up here, folks, okay? Eyes need to be up here because you're not going to get this if you don't see what we're doing. Want to wake him up back there? There we go. Just pay attention. You're not going to learn this by osmosis. All right? So we got to be able to set up and solve an equation here. Pick a variable you want to work with. You want to work with the x or the y's. It doesn't matter which one you pick first. Let's work with y first. Okay, so here's one angle that has the y, and here's the other angle that has the y. Now, before I even get into it, common sense can kind of kick in here. I realize that may be a challenge sometimes for teenagers, but common sense can kick in. I can look at it and say, wow, that's an acute angle. That's an obtuse angle. They aren't going to be congruent, are they? So am I going to set them equal? Would it make any sense at all to set them equal to each other? No. So even if I can't remember the angle pair name, I can figure out just based on the fact that one's acute and one's obtuse, I'm not going to set them equal to each other. That wouldn't make sense. So if I'm not going to set them equal to each other, what do you think I'm probably going to do with them? Add them and set them equal to 180, because what type of a pair are these two? They're a linear pair, which means they are adjacent and supplementary. There it goes. See, it works together. So 2y plus 3y plus 30 is 180. And now I can just solve that. 5y plus 30 is 180 minus 30. 5y is 150. Divide by 5. Y is 30. Marvelous. I'm done with the y's. I didn't even look at the x's. Now we'll go and switch gears and look at the x's. What's the relationship between the x's? Same relationship, isn't it? Oh. So what we're really doing is using one picture to get two equations. That's 5x minus 95 equals 180. Add 95. I have 5x is 275. Divide by 5, and I think x is 55. Because 5 goes in 27 5 times is 2, 25, yep, 55. do you see how we set that up? It requires us to use a couple things. One, maybe some common sense. Two, our knowledge of the angle pair relationships. It would be hard if you try to do the vertical angles here. That would be a much harder problem because you'd mix x and y's. I mean, yeah, I could say 2y equals x plus 5 and 3y plus 30 equals 4x minus 100. And then I could gather them into two equations and two variables and use substitution or elimination to solve for one variable and solve for the other. It's doable. It just takes forever and it's much harder. So try, if possible, to just work with one variable at a time. Okay? Are there any specific questions that you guys have from last night's homework that you were supposed to do that maybe you got stuck on and just said, I'm not sure how to proceed, that we haven't already kind of covered how to go over today? Because it's not due till tomorrow, so you can ask your question right now and help a whole bunch of people. The other homework that we had that we skipped but is pretty straightforward. It's much easier. It doesn't use nearly as much algebra. It's just saying, oh gosh, I've got an angle that's 89 degrees. What's the measure of its complement? Complement means add up to 90. So if I have 89, what would the measure of its complement be? 1. All right? Identification, vocabulary, these things, even just a little plain old common sense, these are all things, if you slow yourself down and stop rushing to the answers, a lot of times the setups are going to be very apparent, almost obvious, and you will get them if you take the time to think. All right? Any other questions? Otherwise, you can have the rest of the period for working. And we got good 10 minutes left. You can really make some progress. And I can come around and help you as you need it. Just a moment. Let me stop the podcast.